So Unit 2, Lesson 2.3, so the sum and difference rules. Sum rule, we're going to do both of them, they're going to be essentially the same. The sum rule gives a simple rule for finding the derivative of a sum of two functions. So for like adding two functions, we have f plus g. We've done that with our our function notation, our composite functions, and pre-calc review. So f, all it's saying is if you want to find the derivative of f plus g prime, that's simply essentially the prime of f plus the prime of g. Okay, when I say prime, that means derivative. That's what that little tick at the top means. Okay, so f plus g prime is the same thing as f prime plus g prime. Okay, don't let this right here confuse you. That just means derivative with respect to x of f, derivative with respect to x of g. Okay, they're functions of x. G of x, f of x, right? So they all have x's in them. Okay. Derivative. Differentiation, derivative. Okay. And then conversely down here, the difference rule is the same. F minus g prime equals f prime minus g prime. Again, this time I'll just refer you. The proof of this is in your book, okay? But I will just tell you how the proof works is they just take two functions and they just do the derivatives of each along with the limits, and at the end it's f prime plus g prime. That's how the proof works out, just so you know. All right, so let's just do an example of one. So if I want to, if f of x is 2x to the fourth plus root x, so this isn't two different functions, it's one function, but they still have two pieces, right? They have two different, like root x and 2x to the fourth aren't like terms, they're different terms. What's that? So yeah, we're just going to take the derivative. Essentially we're doing f prime here. Okay, so and don't overthink this. All this means is we're taking the prime of both pieces. That's all that means. Yesterday, all we did was just one term. Just now with the sum difference rule, you just do it to both pieces. So what's the derivative of 2x to the fourth? 8x to the 3, good. And then what's the derivative of root x? Right, so we change it to x to the 1/2. Makes it 1/2 x to the whole half, so it puts it on the bottom. So that's going to be plus 1 over 2 root x. Right? Because the negative pushes it down. That was from yesterday. And I will say this is the one where the root x ones is the ones they try to use to challenge you in your homework and stuff. So get used to that idea here. This guy being that. Okay, part B. Let's switch to black here. Okay, so now the point is I'm essentially doing it to all four. Okay, I'm taking a derivative of all four things. That's all sum difference rule is today. So with that being said, we'll kind of go around here. So Rye, what's the derivative of the first piece? Good. Okay, and Abby, what's the derivative of the second piece? Good, and we keep the negative. Okay, Rachel, what's the derivative of the third piece?
1.
Nope. -2, yeah. Just because it's a negative already. Because remember, derivative of an x, the x just goes away. Because it has a 1, you drop a 1, nothing changes. So we take a derivative like a 2x, it's just a 2, like she said, but the negative in front. And then Kate, what's the derivative of a constant? Just 0, so this thing's just gone. So this right here would be your g prime. Sorry, I ran out of room there a little bit, but that's it. Are we good with that? We're going to be quick. I got 2 more. Okay, so differentiate this. So right now, we don't know the chain rule, and we will use a chain rule for this later. So what would you do, based on the rules you have, to take the derivative of that? Yeah, like, I know what you're saying. I would FOIL this out, right? I want to FOIL this out, so I like to just write it again and just multiply it out. X times x, I get x squared. X times a -2 root x is a -2x root x. I get that again, -2x root x. and then I get 2 root x times 2 root x is going to be 4x. Okay, I just foiled there. If I did something you don't understand, ask. Okay, so then we would like to get everything in terms of, like, we want to write, to do derivatives, we like to get these up, right? Okay, so what I'm going to do is, we can actually do a couple things. Let's do this first. Let's put this together. That's going to be negative 4x over root x, right? And then that's going to be plus 4 over x. So now we're going to move stuff up. Or we don't have to move stuff up because this is an x to the 1 over an x to the what? And what do you do with exponents in division? You subtract. So what's 1 minus 1/2? 1/2. So this essentially is 4x to the 1/2. What would I write the next one as? If I move that up, it's now a negative 1. 4x to the negative 1. Okay? And now we're ready to differentiate with our sum product rule, or sum difference rule. Derivative of that is, let's see where we're at. We did carry. Kristen, what's this one? Just 2x, good. And Morgan, what's the next one? Okay, good. And we'll change that in a second. And the last one, Tyler?
Negative 4x to negative 2.
Good. You minus the 1. Good job. Okay, so now let's go ahead and these, a negative 1/2, we should understand by now what that looks like. That's going to look like this, right? It's the radical on the bottom. Moved it down to radical on the bottom, square root. Okay, minus 4 over x squared. And that's your answer. Okay. All right. Sure. All right. So find the equation of both lines that pass to the point 2, 9, and our tangent. Oh, I got it. Okay, never mind. My picture is wrong. So what this looks like is we have a parabola. So sorry, I'm getting ahead of myself. Point 2, 9, and its tangent to the parabola 2x minus x squared. Sketch the parabola and the tangents. So just real quickly, this is 2 minus x. Okay, factored. I just do that to see my zeros. So my parabola here looks something like this. And then I have the point 2, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9, way up here. And I'm trying to find, from this point, I want to go tangent through that side, tangent through that side of the parabola. That's what we're doing. So from that point, we're trying to go tangent to the parabola on both sides, because that point is above the parabola. That's what we're doing, okay? Okay, so our point, the way we represent it as is we have A, and then I'm just making the x's a's. So, just one second. So what this represents is, this is the function, that's your y, and then A is just x. So like this means x and y. So like y is that's what y is. This is just what x is. I'm just using a's. Okay, I guess I could just use x's, but in my notes I have a's. So first thing we want to do is we want to take f prime of our y here. So I'm going to do f prime of x, or just that's our y from here. Okay, derivative of this would be what? What's the derivative of our original function? 2 minus 2x. Good. That's our f prime of x. this right here, just me factored it out real quick. I GCF'd just so I could graph it. That's all I did. All right. Just 1 second. Okay, so back to actually what Morgan just said a little bit ago is that we know the derivative stands for the tangent slope, right? So we understand that this represents the tangent slope, 2 minus 2x for that line. Okay, so now what we're going to look at is we're going to look at it with respect to this point. So, and we're going to get the same thing, so we're just we're proving it, but I'll set it up here. If I did y minus y, and I did x minus x, like this, if I do 2a minus a squared minus 9 over, this is for the slope, we're calling it PQ. We're calling this point PQ. These are a's. Okay, and that's a 9. Okay, and then we're doing minus a minus 2. So what I'm doing is I'm taking my point in terms of my x, y, like it's I'm using the function as x and the function as y and subtracting from the point as x and the point as y to verify that our derivative is correct. So when I do that, this right here simplifies after you factor and stuff, and I'll save you the time, to 2 minus 2a, which is the same thing. Okay? Right, exactly. I'm just doing the slope formula. y2 minus y1 over x2 minus x1. Okay. Since they're equal, okay, we're going to go ahead and put this over here. Like, I want to get rid of this fraction. Whoops. Okay. And we're going to have 2a minus a squared minus 9, and we're going to FOIL this out. Yeah, this side, the left side. Over? No, we don't have over. The derivative, we got the derivative is this, right? And this equals the derivative, so we set two things equal to each other, right? We know that by our rules from derivatives that f of x minus f2 of x, like our second y, whatever, over our change in, whatever, I'm writing this horribly, but over x's is equivalent to the tangent slope. So that's what this is. Okay? Then we know this is actually the derivative because we took it. So we're setting them equal to each other to solve, to get these answers for this point. Yeah, that's where I got lost too. Okay? So now what happens is, this, when I FOIL this out, this turns into 2a negative 4 negative 2a squared and negative 4a. Yeah. Oops, they're minus, it's plus 4a, sorry. 2a squared. Yeah, minus 2a squared. So now, 2a minus a squared minus 9 is equivalent to 2a and 4a is 6a, so we're going to have negative 2a squared plus 6a minus 4. So you guys, back to original stuff, but now we're getting, hopefully we're getting easier. Okay, stay with me. So from here, if you saw this, anywhere you were doing some work, what would you do to solve? We're trying to solve for a right now. That's what we're trying to figure out. Because a, how many points are we expecting? Let's go back to what we were thinking about. We're expecting 2 answers, right? So that's why a quadratic makes sense. That's why having squares makes sense. So what I'm saying to you is if you got this, how would you try to solve it? What would you want to try to do to solve that? Yeah, combine like terms get one side equal to 0. Okay? Combine like terms get one side equal to 0. So that's what we're going to do. We're going to add 2a squared over. We're going to minus 6a. We're going to add the 4 over. So I'm going to add the 2a squared, minus the 6a, add the 4. So that gives me a squared minus 4a minus 5 equals 0. Now see if you can factor that. Yeah, sorry, I better write a, yeah. Okay, so right, it's a minus 5, a plus 1. So, by solving by factoring, what are your answers for a? 1's 5, 1's negative 1. So we just figured out what a is. That's what the two a's are for our two lines. What does that represent? The x's. Okay, that represents the x's. And now we want to figure out what the y would be. And so to finish this out, I plugged in what 5 is. So what is 2 times 5? 10 minus 25. So 5, negative 15 is where that tangent line is going to go through. So 5, negative 15 would be way over here. That intersect, yeah. There's 2 points that it hits. And then the other one would be negative 1, which would be negative 2 minus 1 would be negative 3. Oh, excuse me. Okay. So that is the 2 points that intersect. All right, so now we want to get the equations. So, tangents. Good. And good. All right, so we have 5, negative 15. So 5, negative 15. What was our other point? 2, 9? Is that original? So we'll just use that to find the slope, because that's the slope of the lines. So it would be 9 minus a negative 15 over 2 minus 5. That'd be 24 over negative 3. Negative 8 is my first slope. Okay, because this is my original point that we're coming through. This is where it comes through in the parabola. So we figured out the slope of that line. So y equals negative 8x plus b. I'll find the other slope real quick while we're in that pattern. So I'll go 9 minus a negative 3 over 2 minus a negative 1. That's 12 over 3 for a slope of 4. So my other line slope is 4. Now we can plug 2, 9 in. We can plug any point we want. Actually, no. I'd plug 2, 9 in because that works for all of them. 9 equals negative 8 times 2 plus b. Add 16. Add 16. We get 25. So this one's equation, negative 8x plus 25. Okay, doing the other one here. 9 equals 4 times 2 plus b. 9 equals 8 plus b, so b equals 1. So this one's equation is that. So those are two equations of lines that go through that point and hit the parabolas at one spot, the tangent spot. Okay.